In this chapter, we are going to understand the central limit theorem. We're also going to learn how to make confidence interval for the sample mean, learn about the t distributions and when to use the t distribution, and then solve some problems. In the previous chapter, we talked about proportions. It is not always the case that we are interested in yes or no situation. Sometimes we are also interested in the average. And so that is what we are coming to do today. The average is like the sample mean. What is the distribution of the sample mean? So before we proceed, let's try to get the idea behind the central limit theorem. And I'm going to explain that using this graph. So when we look at this graph here, the first graph here, which is this one, this is the first one. So I'll label that 1, 1. We can see that this histogram is heavily skewed, right? And then we can also see that this is the original population. So this is the original population, and then we try to construct the histogram of the original population. And we can see the histogram of the original population is heavily skewed. Now, what the central limit theorem is saying is that regardless of the parent distribution, so for example, this one, the parent data is heavily skewed to the right. Now, if we decide to take random samples and then we compute the averages, we do that several times and we try to plot the histogram. So the second one, which I'll label 2, is a histogram of the sample mean, but the sample size is 2. So we pick 2 people from here and then find their mean, we plot. Pick 2 people, find their mean, we plot. And we do that several times. And we can see this is also still skewed. Now let's come to 3. It is the same idea, but the difference between 2 and 3 is that for 3, the sample size is what? 10. Is that okay? So now we pick 10 people here, find their mean, we plot. Pick 10 people here, find their mean, we plot. Then we go to the fourth one. Same idea, except that the sample size is 30. So now what can you see? What pattern can you see? Now look at the sample size when it's 2, it's also skewed, but you can see that as the sample size is increasing, so from 2 to 10 to 30, you can see that as the sample size is increasing, the distribution of the sample mean is becoming bell-shaped and symmetric. It's becoming more normal. And then you can see that from the last one, which is the sixth graph. When the sample size is 500, you can see this is what? Very symmetric and bell-shaped. So what the idea behind the central limit theorem is that regardless of the population or the parent distribution, whether it is heavily skewed or not, when you increase the sample size and then you construct the sample mean, as the sample size increases, the distribution of the sample mean becomes more normal and then bell-shaped. This is the idea behind the central limit theorem. And this central limit theorem is very useful and it's also a backbone of statistics. So it's very important that you get the idea behind that. All that I said, I decided to write that down too. So you can also read this. It's the same thing. So no matter the shape of the population, the distribution of the sample means becomes approximately normal as the sample size grows. So this is the formal definition of the central limit theorem. So it states that as n increases, so n is a sample size. As n increases, the sample mean has a more and more normal shape distribution. So the sample mean has a mean of mu. And then this is a standard deviation of the sample mean. So the sample mean has a mean of mu. So mu is the population mean. So as the sample size increases, we expect that the mean should be equal to the population mean. And then the standard deviation of the sample mean. So ST of X bar is sigma divided by root n. And then I decided to also refresh our minds because we have talked about sigma already in previous lessons, but I also decided to also define them for you. It is very important that whenever you see these symbols, you know what they mean. They are going to be tested in your test 3. So for example, you're going to see a problem that says, what is this? Is that okay? You should be able to know this is the what? The population standard deviation. Does that make sense? If you see X bar, what is that? That is the what? The sample mean. If you see mu, what is mu? The population mean. Does that make sense? So you should be able to understand the various variables. So I decided to also write this here for you. So the thing I also want you to write in your note is write the standard deviation of the sample mean to be this. The standard deviation of the sample mean is given by the population standard deviation divided by the square root of the sample size. We will get to a situation where if we don't have the population standard deviation, what do? We will get to that. But for now, know that the standard deviation of the sample mean is this, and then the mean is the population mean. And also, when we know the population standard deviation, we are always going to estimate the confidence interval using the z. So the confidence interval for the sample mean is given by this. You could also write that down. And then this z here is the critical value. And we are going to read this z from the distribution. And then we don't even need to worry about that because we know how to get the z from StatCrunch. Does that make sense? When we are dealing with proportions, we use the z to get the critical value. So I want you to note that this is the confidence interval of the sample mean when the population standard deviation is known. Any questions so far? Let's proceed. There are some conditions for us to also assume the normal distribution when we want to use the sample mean. And then just like when we were dealing with proportions where we looked at those conditions, the sample mean also has some conditions if you want to use the normal distribution. First and foremost, the sample size has to be what? Random or simple random sampling. And then should be what also less than 10% of the population should be sampled. I think these two we already spoke about them in the when we are dealing chapter 16 with the proportion. And also if you want the samples, we want the sample size to be large enough so that the shape looks more normal. For example, we want the sample, you see, when the sample size is large enough, the shape looks more normal. So these are the conditions that the distribution should meet so we could be able to use the normal distribution. And so before we proceed, Let us try to open your chapter 17 homework and let's do question 1. Chapter 17 homework and let's do question 1. So to do question 1, my problem says that a food company sells salmon to various customers. The mean weight of the salmon is 39 pounds. So you see here, you've been given the population mean. The mean weight of the salmon is 39 pounds. So let's write that. So we have the mean to be 39. With a standard deviation of 2 pounds. So you have also been given the population standard deviation. So this is equals to 2. Now, it says that the company ships them to restaurants in boxes of 4 salmon. So when they ship to the restaurant, the number of boxes, the number of salmon is what? 4. To grocery stores in 49, to the grocery stores in cartons of 49 salmon. So I want you to write down restaurant is 4 salmon. So I'll write it here. Restaurant n equals 4. Grocery store grocery store 49. And then when they send them to discount outlets, it goes in pallet of 81 salmon. So discount, what's the name? Discount outlet stores. So for discount outlet stores, N is 81. Now, to forecast cost, the shipping company department needs to estimate the standard deviation of the mean weight. So they want what? The standard deviation of the mean weight of the salmon in each type of shipment. So they want what? The standard deviation of the mean weight. Is that okay? So first and foremost, find the standard deviation of the mean weight in each type of shipment. The first one, we want to find a standard deviation of the mean weight of salmon in the boxes sold to restaurant. So what do we know about standard deviation of X bar? We learn from here that the standard deviation of X bar is given as the population standard deviation divided by the square root of n. So it's the same thing we want to apply. So for the restaurant, what is the population standard deviation? This is the same as population standard deviation divided by root n. So for the first one, we are looking for what they send to restaurants. So what is the population standard deviation? 2 divided by square root of 4, because we are interested in restaurant, and restaurant, the n is what? 4. Does that make sense? So what would you get? So that's going to be 2 divided by 2, isn't it? So that's going to be 1. The next one is that we want to find the standard deviation of the mean weight of salmon that is sold to the grocery stores. Same idea. Standard deviation sold to grocery store. So sigma is still 2. Sigma is still 2 divided by root. So for grocery store, it's 49. Square root of 49 is 7. So what is 2 divided by 7? So when you do that, I got 0.2857. We want to 2 decimal places. And then the last one, we want to find the standard deviation of the mean weight of salmon and pellets to the outlet stores. Same thing. 2 divided by, so that one n is 81. Square root of 81 is 9. So this is the same thing as 2 divided by 9. And I think that is 0.22. And then let's do the last one. The last one says that, were you all able to get the A part correct? Okay. So let's do the last one. The last one says that, now this is what they are telling you. They say that the distribution of the salmon weight turns out to be skewed to the high end. Now, would the distribution of the shipping weight be better characterized by a normal model for boxes or pallets? So now we know that the parent distribution or the main population is skewed. Is that okay? Now they are trying to test you about the distribution of the sample. So now, which of them would be more normal? And so when we look at that, remember when we learned about the central limit theorem, we learned that what as the sample size increases, then the distribution becomes more normal. So when we look at this one, so we know that the pallet, because the pallet has a higher sample size of 81. So then the answer is the pallet, because regardless of the underlying distribution, the sampling distribution of the mean approaches the normal as the sample size increases. So that should be how you do question 1. Okay, now let's proceed. Now we want to answer some problems on the sample mean. So let's look at this example here. Now, this example says that a wildlife scientist studying a certain species of frogs know that the adult should weigh an average. So you see, you were given mu to be 118 and a standard deviation of 14 grams. So we know ST equals 1,4. Now the question is that a random sample of 50 frogs gives a mean weight of 110 grams. So from here we can see N is 50, X bar is 110. I am using X bar because X bar is the sample mean. Is that okay? And then this 110 is based on a sample of what? 50 frogs. Is that okay? That is why I used X bar for that. Now they are trying to ask you, is this unusually low? To be able to answer that, we would need to compute the z-score. Is that okay? Remember in our previous chapters, we learned that the z-score is equal to x minus mu divided by this. This is what we know in the previous lessons we've learned earlier on. That is how to compute the z-score. Now, the point is that in this situation, we are dealing with the sample mean. Is that okay? So to compute the z-score for the sample mean, we are just going to modify this formula a bit. So we are going to have the z-score to be equal to the sample mean minus this divided by the standard deviation of the sample mean. And we know the standard deviation of the sample mean is given as sigma divided by root n. Is that okay? So now let's try to find what is the standard deviation of the sample mean. We know the standard deviation of the sample mean is given as sigma divided by root n. We know from the problem that sigma is 14 grams. Our n is 50. So we know the standard deviation of x bar is given us. So now let's try to compute that. When we do that, we get the standard deviation to be 1.9798. This is the standard deviation of the sample mean. Any questions on that? Why did I do this? So you can see from this problem, you were given a standard deviation of the population. This is the mean, this is the standard deviation. You were given ahead. Is that okay? So we can compute the standard deviation of the sample mean. Now to compute the z-score, x bar, our x bar is the sample mean, which we are given a mean weight of 110. So 110 minus this mu is the population mean, which we were given to be 118. Divided by this, we got 1.9798. So what is our z-score? So we just need to do this on our calculator to get the z-score. When I did that, I got z-score of negative 4.0408. The question is this unusually low? Yes, it is unusually low because you can see this is what? 4 standard deviation to the left of the what? Of the mean. So that is how to answer this problem. Now let's get to 2. For 2, we are going to use StatCrunch to answer 2. So I want you to open StatCrunch. What percent of similar samples would have an average weight? So we are trying to find probability that X bar is less than 1, 1, 2. That is what we are looking for. Is that okay? And then we are told that what similar samples, that means that what N is also still what 50 here. Is that okay? So now open StatCrunch. So you see, I have my StatCrunch opened, and then all you have to do is go to Stats, Calculators, and then we go to the normal. Is that okay? So we go to Start, Calculators, Normal. We click on this here. What is the mean of the sample mean? We have the mean to be 118. What is our standard deviation? Remember, we said from here that the sample mean has a mean of mu and the standard deviation to be sigma over root n. And then sigma over root n, we had 1.798. So that is what we are going to use, 1.9798. Now be very careful. You shouldn't put 14 here. Is that okay? Because the question is asking you about the sample mean. So you need to input the mean for that and then the standard deviation of that. Is that okay? We've already talked about it here, that the sample mean is approximately normal with the mean equal to population mean and the standard deviation equal to sigma divided by root n. That is what we have to input in StatCrunch. Is that okay? So now we have been able to do that. Yeah. So now I want to find the probability that the percent of similar samples would have an average less than 112 grams. So all we need to do is to change this to 112. I repeat again, don't put 14 here. Is that okay? We are dealing with the sample mean. The sample mean has a distribution where the mean is equal to the population mean, which is here. But the standard deviation is not equal to the population standard deviation. The standard deviation is equal to the population standard deviation divided by the square root of the sample size. So that is what you have to put here. And then you hit compute. When you hit compute, this is the answer, 0.0012203. Now let's get to the 3. We want to find between 115 and 120. To do that, we just go to click between, and then we check whether the mean and the standard deviation is still the same, and then we put in those figures. So 115 and then 120. When you do that, you get 0.7789. The fourth one says that more than 125 grams. So to do more than 125 grams, we come back to standard and change this less than here to be greater than, and then we put 125 there. And then you hit compute, and then we get this too. Then the last problem says that what is the fifth percentile? So to get the fifth percentile, we change this to less than here and put 0.05 here. Is that okay? No, we put 0.05 here. 0.05. So if we want to compute the fifth percentile, we put 0.05 here. It's the same thing like we've done in previous chapters. If you want the 95th percentile, we put 95 here. 0.95 here. So if you want the fifth percentile, we put 0.05 here. And then you hit compute, then it computes this for you. So then the fifth percentile of the average frog weight is 114. So I just wrote out those answers here. Now, we are coming to talk about situation when the population standard deviation is not given. So when the population standard deviation is not given, so it becomes unknown. Is that okay? When the population standard deviation is not given, it's unknown. We do not know that. Is that okay? And so we are going to use the sample standard deviation to estimate that. Is that okay? If this guy here is what? Unknown, we will use S is a sample standard deviation. We are going to use S to what? Estimate this. Is that okay? And whenever you use S to estimate this, now this is not normal again. Now this, we are going to use the student T distribution. Is that okay? Whenever you use a sample standard deviation to estimate the population standard deviation, we are going to use, it's going to follow the student T distribution. So that is one thing I want you to draw your attention on. When the population standard deviation is known, we are using Z. If it's unknown, we estimate that using the sample standard deviation. Whenever we do that, the distribution is going to follow the student T distribution. So I want you to note that. So I went ahead to write these notes for you. When we will use the student T distribution when the population standard deviation is unknown. Is that okay? So I want, because you are going to have problems that you have to decide whether you are going to use the Z table or the T table. And so one thing that distinguishes between the two, or the main reason what you have to focus on, is to ask yourself, is the population standard deviation given? If yes, let's focus on the Z. If no, let's focus on the T distribution, assuming all the other conditions are met. Does that make sense? So you are going to, in your exam, you have to decide what distribution you are going to use. And the key thing is to ask yourself whether population standard deviation is given or not, holding all other conditions being met. And also, whenever we have the T distribution, we have something we call the degree of freedom. So the degree of freedom is always given as, I want you to also write this in your notes. Degree of freedom is always n minus 1. The degree of freedom is n minus 1. And then don't forget, S is the sample standard deviation. the confidence interval for the t is giving us this. Now you realize that it is similar to the z, except that we are going to focus on the what? The t distribution, and then the sample standard deviation. We are using the sample standard deviation to estimate the population standard deviation. So it's the same thing, but except that the critical value is not z, it's going to be t with degree of freedom n minus. This n minus 1 is a degree of freedom. Is that okay? So then this is the degree of freedom, and then this is the confidence interval. On Friday, we will do problems on both the z and then the t. So just know that this t n minus, this is the degree of freedom, which is n minus 1, is the critical value. Usually when you see some stats book, they will write t minus 1 and then 1 minus alpha. But here, you are not going to use the t table to read. We are going to use StatCrunch to get a critical value. So I decided to ignore this 1 minus alpha and teach you how to use StatCrunch to get the critical value. So don't forget the standard. So because we do not have the population standard deviation, the standard error of the mean is giving us s divided by root n. This is the degree of freedom. Now, we are going to learn how to use the t-test. And then before that, let's try to answer, open to chapter 17, homework question. We are going to do question 3 and 4. So I want you to open question 3 and 4. So the first thing I'm going to teach you is how to get a critical value for the t. You know how to do for the z. Let's learn how to get a critical values for the t. And based on that, we are going to answer question 3 and then 4. So now they are saying using t-tables, which we are not going to use in this course. Here we are going to use the software with the StatCrunch to calculate the critical value. So to compute the critical value for the t, now let's look at what we are given. We are given the degree of freedom to be what? 12. Is that okay? Correct? Okay. If that is correct, we also know if the degree of freedom is 12, what is the formula for the degree of freedom? We know the degree of freedom formula is n minus 1, right? From here, isn't it? So if the degree formula is n minus 1, what is n? Who can tell us what n is? What is our sample size? 13. Does that make sense? Good. So go to StatCrunch. Let's get to stats. So I'm going to teach you how to use the t, how to read the critical value. Is that okay? Let's get to stats. Let's get to t stats. One sample with summary. Does that make sense? Okay. For today, we are just going to learn how to just get the critical value. On Friday, we are going to learn how to get a confidence interval and everything. Is that okay? So today, let's focus on getting the critical value. Regardless of whether we want to get, whether the confidence interval, the critical value, we still have to go through this approach. Is that okay? So we click on this one here. The first thing we want to fill out is the sample size. What is our sample size? 13. Is that okay? That is for my problem. I don't know for what you have. So you put 13 here. You have to get that correct. Is that okay? Now let's change this to confidence interval, okay? Remove it from the hypothesis test and then bring it to the confidence interval. Is that okay? So when you bring it to the confidence interval, now click on show critical value. Is that okay? Good. What is the confidence interval? We are asked to find a critical value for the 98% confidence. Is that okay? In my problem, it's 98% confidence level. So I come here, I change this from 95 to 0.98. Is that okay? Good. Now we just want we just want a critical value. Let's try to put any number here. Sample mean let's put 2, let's put 4, standard deviation, let's put 2. It doesn't matter. Is that okay? We are not interested in the confidence level now. We just want the critical value. The critical value doesn't depend on the sample mean or the standard deviation. Does that make sense? So when you do that, you just hit compute.
So it's like the same as like the critical Z, it only is based
Yes.
off of the
Yeah.
like sample size.
Mm-hmm.
Cause and the percentage, right? The
Confidence.
confidence percentage.
Yeah.
Okay.
So you can see critical T. Do you see critical T? Now that is what you're gonna get. So here it is 2.68098. So you just come to start crunch and then input it. We want to 2 decimal places. So 2.68. Now let's do for the same thing. Now I want to find 90, we want to find a critical value for 99%. So if the degree of freedom is 58, it means that the sample size is what? 59. Is that okay? In your exam, you are going to have problems that maybe they will not give you the degree of freedom, but they can give you the sample size and tell you to find the degree of freedom. For example, if the sample size is 59, degree of freedom is what? 58. Is that okay? So here we want to find a critical value for T, 99% confidence interval. Degree of freedom is what? 59, 58. So it means that start crunch. Let's just go to options, edit. Let me change this in a sample size to be 59. Is that okay? Because I was giving degree of freedom to 58. And then here is what? 99 confidence. So we just click compute. And then we get the critical value to be what? 2.66. Now, question 4.2 is the same thing. You are going to find a critical value for 95% confidence interval with the degree of freedom to be 10. So I'll just do the A and then you can proceed from the rest. So option 95, you change this to be 95. And then degree of freedom is 10, so sample size is 11. So you see, T is 2.228. So you see, that is how to get the T critical value. Is that okay? On Friday, we are going to proceed to now construct confidence intervals for T. I will also find examples for Z2 so that you know the difference and you know what to do whenever you have any question. So I'll see you on Friday.